continuing what we started last summer. So you new people are strategically placed around returning people who can help you get caught up, but I think you'll be just fine with this. And so my main focus is putting algebra and geometry together because it's so much more powerful when you have them both together, and that is really the push for mathematics now, is to embed algebra actually into almost every other strand of mathematics because it's such a neat issue. And I know my husband sent me a cartoon yesterday that said, gee, I don't think I've used algebra at all today, but that was a housewife, which was very offensive to me. Not because she was a housewife, I don't mind housewives, but they actually do use algebra, they just don't realize they're using it all the time, okay? When they're cooking or whatever they're doing, they're using algebra. So I hope this thing works. Miss Laura?
Yes, ma'am.
Is there an on button?
Yes.
That's
On the side,
Is it on?
right there on the side.
I turned it on, it didn't
Just hitting the wrong button. Yeah, the light's on.
Okay, so, geometry and algebra together, we'll soon be able to do this. So, we talked earlier this morning about the national standards for mathematics, and they come from NCTM, which stands for National Council of Teachers of Mathematics. You may ask people who are members, raise your hand. Okay, I only see 1, 2, 3, 4, 5 maybe.
Is that the one you're a member of if you go to camp?
No, that's TCT.
That's the Texas chapter of NCTM. So you really need to join NCTM if you teach mathematics. Science people should also as well, but I know that you have your own organizations to join. But it allows you to go into their website, which has just a ton of activities for you. There's eliminations, which is you've got virtual things you can do. There's a journal that's on there. It's just wonderful.
She just put it.
She did? All right, great, good. So their main things are, these are what they really want to do. They want the students to learn the value of mathematics and not just to see it as something that they have to do. Because many times people don't like mathematics. I teach math methods to EC6 candidates, and a lot of my students want to teach kindergarten because, quote, they don't have to teach math in kindergarten. Is that true, Teresa?
Right, so the basis of that.
It is. So all of the TEKS, the algebraic strand, all of that begins in kindergarten. So you have to teach math in every grade. I had one student walk in and she said, I hate math, I'm going to fail this course. I said, okay, welcome. What else could I say? So I want the students to be confident in their ability. Now this is a biggie for me, this confidence. I want them to be confident that they can figure things out. And that doesn't mean that the first time they read it, they're going to go, oh, okay, I got that. That they have the perseverance to think through it and to figure it out. So I hope y'all do that today when we get these activities. I want them to be problem solvers, learn to communicate, which we do all the time. We talk with each other, we talk with me, we make our chart papers that are going to go up on the wall to communicate to the whole class, and to reason. So about geometry, it's really just a spatial sense. Some people are more spatial than others. My younger son is extremely spatial, and I attribute that to me taking pattern blocks home from the age he was 2 on, and he would make these huge mosaics with pattern blocks in the middle of the floor in the living room in the summer. That's how I kept him busy, because he was really a very busy child. So pattern blocks have attributes such as congruency and angle congruency and all, so it was a very spatially rich atmosphere for him. So then there's the Van Heelys. This is a review. I hope you people coming back are remembering all of this. So tell me, Cameron, you remember the Van Heelys?
No, I'm sorry. That's burning it up.
Husband and wife,
Yes,
educators,
yes,
studying with as students, thinking while solving geometric tasks.
that's right. They studied thousands and thousands of students. They're Dutch. And they studied thousands of students. And they came up with these 5 levels of
Oh.
geometric thinking.
Okay.
The visual level, the descriptive level, relational level, deductive level, and rigor. And since they were Dutch, they started with 0 and then went up. So the visual level, you have to begin at the visual level. These are hierarchical, which means you can't skip from visual down to rigor. It just won't happen. You have to go through all of those steps. It's kind of like, well, almost it's kind of like childbirth, but some of y'all wouldn't understand that. You know, you can't skip steps in that. So you have to start at the beginning and go. So the visual level, a kid can pick up something and say, that's a triangular prism. I don't think it's a prism, but whatever this is, that they can recognize the shapes. Oh, it is triangular prism. Thank you. They can recognize the shapes. This is a triangle, this is a rectangle, visual. But they can't really tell you the attributes. What makes it a triangle? What makes that a rectangle? What's the difference in a rectangle and a square, if there's any difference at all? So that's the visual level. They can't do that. In the descriptive level, thank you very much. The descriptive level, they can describe it to you. They can say, okay, a triangle has 3 sides. This happens to be an isosceles triangle because 2 sides are congruent. This is a rectangle because it has right angles, and these 2 sides are parallel to these 2 sides, okay? And then there's the relational level where they can tell you the difference in a square and a rectangle and why a square is a rectangle, why some rectangles are not squares, okay? They have to get through the relational level by 8th grade, by the end of 8th grade, or they will really struggle in high school, and most of them will hate geometry in high school and fail. How many of y'all really love geometry? Good. How many of you did not really love geometry? You know why? You did not have enough hands-on activities to get you through those 3 levels.
We had pen and paper.
You had pen and paper, that's all. And memorize it. Memorize it. You have to have hands-on activities to get through these 3 levels by the end of 8th grade. I mean, hands-on, measuring, you know, all of that. So, the deductive level is high school. That's high school, where they can they have an axiomatic system. Remember Euclidean geometry, plain geometry in high school, named after Mr. Euclid, Euclidean geometry, where you have theorems and postulates and definitions and all of that you gladly memorized, and you could prove that two triangles were congruent by side angle side or side side or all of those things. Okay, that's deductive. You have an axiomatic system. High school geometry, making connections. And then rigor is more college level, where you can bounce back and forth between axiomatic systems. You can go from Euclidean geometry to Riemannian geometry to Lobachevskian geometry to all the other transformational geometry, all those geometries. You have time to be really a geometry nerd to take those courses, which I was. I took a lot of it in college because I really love geometry. But that's college level. So how far do they have to get before the end of the 8th grade? Through relational, level 2. They have to be pretty darn good with it. Through relational before they get to high school, all right? So I want you, if you have your shapes here, I want you to open that. Don't have any shapes, I have some. All right, so if you have your shapes, Martin's going to give some shapes to some people that either could not get to your shapes or haven't gotten your shapes yet. Shapeless.
We're shapeless.
So, he's coming.
Start a sign out sheet, have them sign.
That's Okay. If I can have your attention again. If you have some shapes at your table, I would like for you to hold up a rectangular prism. Hold it up high so I can see it.
Okay.
I do not see everyone holding up a rectangular prism. Stand go forward and everyone does. Brenna, don't hand it to Okay.
Well, this one's missing.
Down.
Yes, that was it.
You don't have one.
He told me there was set two, so I just, This one's missing.
It's missing what?
Upon opening. Yes.
Okay, it wasn't sealed.
That one was not
This one wasn't sealed.
Okay, if I can have your attention.
Here.
Everyone is holding up a rectangular prism. Alright, so I want him to explain to me why that is a rectangular prism. And as you're explaining, I want you to hold that up and physically touch what you're talking about when you're telling me the attributes of a rectangular prism.
You see the fear in my face.
Don't be afraid, we all love each other around here.
Yeah, there was a
It's a prism because it has two
We should
parallel,
all be listening to Kim, there should be no chatter. Go ahead.
actually it has four parallel. Four,
You can only have two at a time.
two congruent, two parallel sides, yes, no?
Hold that back up the way you were holding it, where your fingers are
Where my fingers are,
parallel and congruent.
parallel and congruent,
So those are the bases.
parallel and congruent.
Those also are parallel and congruent, so those could also be considered
Bases.
bases. We'll go back to your original. All right, so it's got two parallel congruent bases. All right, now what else does it have?
90-degree angle.
It does indeed. Does everybody have 90-degree angle?
Yeah.
All right, go ahead.
And split it down the middle and make two triangles.
You could. Now, we haven't discussed that yet, but if your students were ready for that, you could talk about that.
It's a prism because it has a face.
We've already agreed it's a prism, so
Okay.
tell me more about it. Tell me, what is this?
Vertus? No. Hold on.
This, where these two faces meet,
The two faces meet is an edge.
is an edge. Good. How many edges does it have?
8.
It does. Brenda, how many edges does yours have?
12
12, it does.
edges.
Laura, how many edges does yours have? Good. 12? How did you get that? You want to tell Kim how you got that?
I missed the two, I missed 4. I figured,
Which
I
four?
had phoned a friend.
Good. Which four did you miss?
I missed the short here and here.
Okay, all right. Many times the kids will get the 4 on the top of the base and the 4 here, and they won't get the 4 vertical ones going up, okay? All right. Had I had all of these out this morning when we were working on this, these are the types of questions I would be asking you. But since you didn't have them and we were short of time, I didn't stop to pass these out, okay? That's the kind of questions I would be asking, all right? So now, when I asked you those questions, what level were we on? Hang on. Wrote the cardinal rule. Cardinal rule. That was a plural response question. All of you were talking at one time. I heard almost all of you, but I don't want that to happen. So,
Wasn't descriptive, because you have somebody explain their reasoning or why they thought their shape was a.
That is correct. It was descriptive. It was past visual. You recognized it as a prism immediately. So you were describing. It was past visual. To get to relational, yes ma'am?
To get to relational with, because I thought maybe we would have already got there, because we were talking about the sides in relation to the edges and vertexes. So I thought we were going to see the relational.
To get to relational, you borrow this? Thank you. May I borrow yours? How are these related? What are their similarities? What are their differences? That's relational. Okay? That's relational.
Was it because you had to point to and touch the stuff that was now descriptive?
Yes. Yeah, she was telling me the attributes. This is an edge, this is a vertex, this is, it's got 12 edges. That's
So what would the
descriptive.
difference then be between the visual and the descriptive? Just saying without touching it?
This is a cube, that's all I can tell you. I don't know how many edges it has, I don't know how many vertices it has, I don't even know how many.
Just like you're a
faces.
man, but,
Yeah,
you know what I mean, that's visual.
What did
You're
you-
a man.
yeah, just recognize it. Thank you, very nice analogy. So, we're comparing these, you listening? What level are we? That's relational. And then when you get to high school, you're tearing apart those composite figures to prove triangles, congruent or not. Okay? So, a rigor, remember, is college level where you have different axiomatic systems, and unless you're a real geometry nerd, nobody in here probably took those courses. Okay? So here are the levels. They start with recognizing shapes. And they talk about classes of shapes. This is still visual. This is a square, this is a triangle, classes of shapes. Then they talk about the properties of the shapes, which is what Kim was doing, right? Then they talk about relationships among the properties. That's informal deduction. That's relational, informal deduction. And then high school, and then college, okay? These are hierarchical. You have to go through each stage in order. However, they do bleed over each other sometimes. So a kid can be visual for some things, but also descriptive for others. And they can describe a triangle, but they cannot describe a cone. Okay, yes ma'am?
So would that also be, for example, what he was asking, that you would say, oh, it's a shape, that's just being descriptive, and then, I mean, visual,
Visual.
and describing it is a.
Describing it is descriptive, which is this level 1. You can tell the attributes, that's a key word, the attributes, all right? So it's not hard and fast. You know, they don't just jump from here to here and from here to here. They kind of blend over each other. Just if you have children, you know how that goes. If you teach, you know, kids don't jump from fractions to decimals all of a sudden. They kind of blend them in together and then they go, all right? But they are hierarchical. You cannot go from level 0 to level 3 without going through levels 1 and 2. Cannot do it. And it does not depend on the intelligence of the child. It does not depend on the age of the child. It depends totally on the experiences that the child has had. So you can have a kindergarten at the descriptive stage and my husband at the visual level. Okay, you can. And of course, he wouldn't be happy if I said that, but he's certainly not up. And we were in the same high school geometry class. I was here. He was here. Okay? As you know, a 17-year-old kid. So it's not age related at all. It's not intelligence related at all. It's related completely to how many experiences you get to work with the kids. All right? So we talked a little bit about mathematical habits of mind, and this second sentence is important to me. It's important that they understand mathematics and not just memorize algorithms, not just memorize steps to do something or definitions. They have to understand it. So here are the geometric habits of mind. Here are the algebraic habits of mind. We talked about all of this last summer, remember? Here is reasoning with relationships, investigating invariants. Invariants are things that change. You know, what happens when you increase the length of a rectangle? What happens to the perimeter? Okay. generalizing, which we did, and balancing this. And then the algebraic habits of mind, doing and undoing, building rules to represent functions and abstracting from computation. So we did Fudge Tray Activity 1. In Fudge Tray Activity 1, Bea is smiling because she loved this activity, right? They were so frustrated. In Fudge Tray Activity 1, they had to make a rectangular tray that would hold, you know, that measured 24 by 20, and they had to find volume and surface area and all. And then we did Activity 2, which changed some of the parameters that they were working with. Well, today, that's the rest of Activity 2. We did all of that, remember? Good. Some of you do, some of you don't. Today, we're going to do Activity 3 and 4. If we get to it, I'm thinking just 3 today, maybe 4 tomorrow. So, I have Activity 3 right here. And since Martin did such a good job of distributing the cubes, I'll distribute that quickly, okay? It'll be easier if you just give a bunch to him and give a bunch to them and let them go. When you get this, everybody gets a copy, and then when you get this, I want you to work with a partner or two. Usually you work with the partner that came with you. Some of you have no partner that came with you, so you'll work with your table mates. I'll let you group yourself, okay? You listening? I'll let you group yourself. 2 or 3, I don't want too many, Martin.
Yeah.
All right. So if I can have your attention for just a moment more, you're going to read the activity and do what it says to do. Be sure that you're working as a student. Be sure that you're thinking as a student. Do not use your teacher knowledge. I don't know if you're using your teacher knowledge, because this activity will take you 5 minutes with teacher knowledge and 3 days as a student, okay? Okay, so do not use your teacher knowledge. Are y'all listening?
Yes. Don't use teacher knowledge.
Okay, no talking, please, when I'm talking. Remember, if you're the math teacher and you know how to do this, then you can only ask questions, and they have to be the type of questions. This is so typical of males. Anytime you give them cues,